Alright, this question is dealing with an introduction to equilibrium. We have a system and we're given concentrations of reactants and products and asked if the reaction is at equilibrium. To do that, we're going to have to solve for Q. Q has the same form as K, i.e. we would calculate it the same way, but we don't know if the system is at equilibrium. The system may or may not be at equilibrium. Alright, so let's proceed with the problem. We have a reaction, N2O4 gas, and an equilibrium reaction, reversible reaction, with NO2 gas. So Q is going to be calculated by the concentration of products raised to their coefficients over reactants raised to their coefficients, 1. We can substitute in our values for the concentrations at a given time, and if we calculate a numerical value, we find this is 4.58. Okay, so now we need to compare Q to K, and that'll tell us whether or not we're at equilibrium. If we're at equilibrium, that would be indicated by Q is equaling K. Okay, which is not the situation that we have here. K is 0.21, Q is 4.58. Alright, if Q is greater than K, that means, well, let's think about this. We know that K is going to have some expression of product concentrations divided by some expression of reactants. If Q is equal to K, there's no change that's going to, you're at equilibrium, there's going to be no change in these concentrations. If Q is greater than K, that means the product concentrations have to become smaller so that Q can approach K. So in this case, the reaction will proceed to the left in order to reach equilibrium. Okay, which is exactly the situation that we have here. Let's look at the other situation. If Q was less than K, that means the product concentration would have to get larger in order for Q to match K. So the reaction will proceed to the right in order to reach equilibrium.